There's an intrinsic relationship between music, visual arts, mathematics, and physics. Most people often look at them as if the logic behind mathematics kind of desensitize mathematics from artistic and creative forms. However, they are one side of the same coin in a way. They talk about the same story in different words, in different languages. Mathematics uses abstraction to explain the world. And once we come from that, we use that abstraction to maybe visualize it using geometry. For example, you could talk about fractals and chaotic systems. In particular, when you look at fractals such as Mandelbrot, you can see that if you plot this particular sequence, you end up with a very beautiful pattern. Artistic in nature, you would swear that somebody actually painted it. However, it is just a mathematical pattern that when represented visually, you see its beauty. When it comes to music, we have sequences like the Fibonacci sequence that if you reduce them in a particular order, and they give you this particular repeating pattern, that you can actually play the music notes and hear the beauty in the music and appreciate it. And in that way, you realize that there's an interconnectedness between the arts and physics and mathematics, because the mathematics, it guides the abstraction of what is happening in the creative's mind. It does not end there. When you look at a lot of people who maybe suffer head injuries in some instances, they'll become savants in either mathematics, physics, and in some cases they can play music quite well. And this kind of gives us a clue that maybe there is a fundamental relation on how we process numbers and how we process art itself, including music, because music is nothing else but repeating patterns expressed in a particular order. It is a language unto itself. We could look at how music is made itself. In particular, we could look at harmonics in physics to better explain how different notes, different pitches are made. To do this, I'll do an experiment using glass wines. I'll rub a glass wine that is empty, and you will hear a high pitch. And I will then vary the different water levels in that glass wine, and you will hear the pitch change. If we have a lot of water in the glass wine, the pitch is really low. It resembles a bass. If the glass is empty, the pitch is really high. This is because the glass has a natural frequency. So when you rub it, the walls of the glass vibrate at a given frequency. And when that happens, you have a very high pitch, for example, because it is not carrying a lot of load. However, if we put water, the vibration of the walls are now damped. There is an additional mass there's an additional mass on the walls of the glasses. So they are not just vibrating themselves, they must also vibrate the water such that energy is transferred from one wall to another. And as a result, we end up with a damped frequency that is lower than the natural unloaded frequency of the glass. And as we keep increasing the mass, the rate at which the walls vibrate, it reduces. Therefore, the pitch that we hear also decreases. Thus, we end up with a more bass-like frequency or pitch. We can also demonstrate this beautiful relationship using air columns, such as a bottle like this. If you blow into it, you realize I've put in water in there. This is to reduce the length between the top of the water and the mouth of the bottle. In a way, it's reducing the length of my tube here, because my tube would only be this section. And as the length of the tube decreases, or your air column, the pitch increases. There's a mathematical model that actually underpins this whole relationship. You can look at it. If you know the length, you can actually figure out the fundamental frequency of that particular air column. So listen to this. Now I've emptied the bottle, and you can now listen to it while it's empty. Essentially, by emptying it, I've increased the length of the air column, and you probably hear a much deeper frequency, which implies a lower frequency, lower pitch in this case. So here goes nothing. We can hear that the pitch indeed is lower in this one, and if we wanted, we could easily calculate what that fundamental frequency is. So we can see that there is an interlocked relationship between how we perceive arts and how the principles of physics explain the world. In a way, if you could understand all of physics that we know and yet to be realized, you could essentially explain all human interactions, including art and music.